Good afternoon, everyone. Hello. And I am Mr. Wojcik. You know that. You know me. And today, we're going to do some more coding with Tracy, the turtle. And we are going to learn a few things about for loops and comments, and that's it. Now, I do understand that a lot of you are all working at different paces. Some of you have been coding for several years. Some of you, this is the first programming class you've ever had. And so here's the general rule of thumb that I'm going to do. Each unit in CodeHS, I'm going to keep all those lessons unlocked. So as I'm going through them, if you want to work ahead, that is 100% okay. I encourage that. But once you get to the end of the unit, it's going to stop, right? I don't want you moving on to go to the next unit until we've wrapped up the unit and taken the test or so forth. So you have two options. All right, you've got three options, technically. If you complete, let's say you get through everything in this Tracy the Turtle unit, then your next options are one, you can play in the sandbox. The sandbox is just one open, fun place. There is no actual sand here, though, so I'm warning you, you might be disappointed. That happens. You can just name any program like trying something fun, and you hit create program. And you can just go ahead and here's the Python category, and you can choose Python Turtle right here to do turtle graphics. Or if you are just curious about some of these other languages, C++ or SQL or Java or JavaScript, if you really want to try something else, you can totally do that in the sandbox. Now, there aren't going to be full lessons, but you can still explore. There's documentation you can look at to try things out. I am totally cool with you doing that. That's probably like one of the more fun things to do. Instead of this, there's also a practice tab. This is a great place to go to brush up on your skills. So if you hit practice, it's got a bunch of just extra challenges for you to cruise through. And so this is a great place to go. You have to choose the language. So I would go down to Python, since this is the Python class. And you've got all of these additional challenges that aren't in the main lesson curriculum. So this is an awesome place to go if you just want to brush up. You know, they're like these little mini puzzles in a way that you try to figure out and solve. This is excellent. Now, all of these practice problems, though, are with what we're calling like real Python. It's not Tracy the Turtle. And so it's going to be just more like typed, like text-based, where it's not going to have a turtle on the screen. It'll have, words or numbers or whatever showing up on the screen instead. And so you can definitely try that out and explore, but it'll mean more once we get to Unit 2 when we are typing more in like real Python 3 instead of Tracy the Turtle. So those are the two coding options you have if you kind of make it to the end of the lessons. But the third option you always have is to work on any other assignments for other classes, okay? So if you catch up to everything I want you for the day, you can use the rest of this class as a study hall. I don't want you, playing Minecraft or doing handstands or, just watching YouTube. I'd rather I don't want you to waste your time. You can play Minecraft if you actually programmed it or a mod or something. I'm okay with that. But we really just don't want you just gaming here unless you made the game yourself. I'd rather you work on your skills throughout the whole time. Okie dokie. Okay. Hold on. Gabe says he can't join. Gabe, are you still having trouble? Type my name correctly. All right, we have one student who's still having some trouble getting on, everyone. I appreciate your patience. Okay. Back to Tracy. Says getting ready and is doing nothing. Try restarting your computer. All right, so we got through these first 3 lessons in Tracy, and today we're going to go through 3 more lessons. Now, we might get through these pretty quickly. If so, I would love to get through functions here, which is a big concept in coding. I don't know if we'll have enough time today, but I'd love to try. So for today, I'm going to go through a few things, give you time to code, and maybe 45 minutes to an hour, then I'm going to bring everyone back again and go over some more concepts once you've had some time to work through these. So let's rock and roll. Starting off for today, we're going to talk about something called a for loop. Now, don't get confused. This is not the number between 3 and 5. This is very different, right, Vegas? Yeah, there's no U. So take a look at this program that you did in one of the earlier lessons. Draw a dash, leave a space, draw a dash, leave a space, and so forth. On the right side, this is all the code that you would have typed to make this program happen. If you look at all these lines, do you see anything that kind of repeats itself over and over and over again? Yeah. Yes, you do, don't you? Look at these 4 lines. So the first 2, pen up and backwards 200, that just takes Tracy from the middle of the screen to the left edge. And then from that point, pen down, forward, pen up, forward. So draw a line, then leave a space. Then those 4 lines just keep repeating all the way across the screen over and over and over again. Some of you, when you programmed this, you probably just copied and pasted once you saw this and recognized this pattern. Well, the cool thing about coding is they make it easier for you to, well, repeat code a bunch of times. You don't have to write it over and over and over again. That's just not efficient. So we want to repeat this section of code a specific number of times. In this case, 4. That's when we're going to use this thing called a for loop. And a for loop is used to repeat code a fixed number of times. Hey, that seems kind of important. Maybe this should go in our Python notebook. Yes, great idea, Mr. Wojcik. Awesome, Gabe is on now. So we are all good to go. So for something like what we have here on the screen, there are 5 circles that Tracy drew. And so we kind of want Tracy to repeat this code 5 times. Draw a circle, pick your pen up, move forward, put your pen down, and then repeat over and over and over again. And so this for loop, and so you don't need to write anything yet. I'll go over this with you on exactly what a for loop looks like. So just take a look up here at the screen. There are 2 main benefits of using a for loop. The first thing is it shortens your code. On the left side, I've got 19 lines of code. On the right side, I have only 5. I'd much rather type only 5 lines of code instead of 19. All right, I've cut this down. I've taken out 75% of the original length. That's huge. Change it. So I've got this circle that's got a radius of 20. What if I wanted to make that radius 50? Back in my original code, every time that I had a circle being drawn, I would have to change this 20 and that one and that one and that one. I had to find all of those and change that number to 50. That's a pain in the butt. Instead, if I've got this for loop that says, hey, repeat this code over and over and over again, I now only have to change it right here. This circle 20, I can just change that 1 time instead of at 5 different places. Now, here's what I want you to write down into your journal. This is the actual syntax of what a for loop should look like when you type it in to Python. For I in range, then in parentheses, you're going to have a number, and that number is how many times you want it to repeat your code. Below that line, you're going to type as many commands as you want that you want to be repeated that set number of times. Now, the one important thing is that all of these commands need to be indented. So you just press the tab key one time and it will bump it over. So here on the right side, this is officially what it will look like to repeat that code 5 times. For I in range, parentheses 5. And then also right here, there's a colon. You need to have that colon. After that, hit enter to go to the next line, and it should automatically tab over. If it doesn't, just hit tab, and you're going to then write as many lines as you want to repeat itself over and over again. So here's our new term, a for loop. Okay, that's our new term we just learned. Now, its classification is something very unique in coding. This is something common across all languages. It's called a control structure. Reason being is it controls the flow of a computer program. Normally, our program runs one line at a time from top to bottom. But if we have a for loop, it'll run down through the for loop, but then repeat those same lines over and over and over again before moving on to the lines of code written underneath it. It's controlling how the program is read. Its definition, this is used to repeat code a fixed number of times. The word fixed meaning it doesn't change. So if I know I want something to occur exactly 7 times, I would use a for loop because I can specify the exact number of times that I want this to occur. The syntax for it, for I in range, and then in parentheses, the number of times you want it to run. So number of each time that it runs through a loop, it's called an iteration. So the number of iterations, which just means how many times you want it to actually run. And then you have a colon. So here's what it might look like for I in range 3. Just like that. Then make sure all the lines you want to repeat underneath it are tabbed over one spot. All right, so that's your for loop. So let's take a look at this. If we want to write a program that has Tracy draw a square with sides of 50 pixels using a for loop. So let me jump into the sandbox real quick. And I just want to kind of show you, demo this on the board for everybody. Tracy for loops, turtles, and let me make this a lot bigger. All right, so we want Tracy to make a square 50 pixels long. So looking at this square, how many sides does a square have? It's got 4, right? So I'm thinking in my head, I want some code to repeat 4 times. Now, Tracy's starting on the bottom of the square. She's going to move forward. And then after she moves forward, what is she going to have to do? Turn. Exactly. Then once you do those exact same things, just 4 times, move forward, turn, and keep on doing that. So I'm going to make a for loop for I in range, parentheses, 4. Because I want this code to repeat 4 times. Make sure you put a colon, not a semicolon. That's a semicolon. I want a regular colon, and then hit enter. Notice how in CodeHS my cursor automatically is tabbed over one space. That's what I want to have happen. Now I can just tell Tracy, move forward 50 pixels. And then I want her to turn left. And do you remember what kind of a number should go inside the parentheses for a turn? The number of degrees. So for a square, how many degrees do I want to turn? 90, yeah, it's a right angle. So this should be all I need. This says, hey, 4 times in a row, I want you to repeat these 2 lines of code. Move forward and turn. Move forward, turn. I can't move my hand that way. Forward, turn, forward, turn. So let's run it and see what happens. Go, Tracy, go. Yay, she did it. So I got to complete this in just 3 lines of code, which is pretty awesome. Now, just so you know, if I had these over on the left side like this and I run the program, it doesn't work. It does not recognize that these 2 lines should be part of the for loop. So in Python, anything that you want to be in this loop, it must be tabbed over. Okie dokie? Cool. And then here's another example of drawing a dotted line. You can just look at that example yourself down here if you want to see how CodeHS goes through with drawing that. So that's the one new command. And it's not a command because it's not telling Tracy, move forward. It's a control structure. It's changing how the code is read. All right. 2 more quick lessons and then coding time. This one is very simple. I actually don't even know why CodeHS made a separate lesson for this. For turning, with our left and right turns, we always put a 90 in for 90-degree turn, but you may have already figured out that you can actually turn any number of degrees. So here's a diagonal. Well, diagonal is half of 90. That's just 45 degrees, and I can do left or right. And so any number I can actually plug in there. Here is a brand new command, though. Definitely want to write this one down in your Python notebook. This is extremely useful. Separated by a comma. And those are going to be new coordinates for Tracy to move to. So remember, Tracy starts off in the center of the screen in her grid world, and she can move anywhere on there. Remember, the X and Y axes go from -200 to +200. So you can specify exactly where you want Tracy to be anywhere in that grid. And wherever she's starting, she'll move exactly to that spot. So here on this arrow on the screen, the command was given to Tracy, set position 100, 100, right here. So from the middle, Tracy went exactly to the coordinate 100, 100. That's pretty awesome. So this allows you to not have to have Tracy kind of walk around the screen to figure out where you want her to go. You can just tell her right away. And if you didn't want her to have this line behind here, what command would you type in first before you set her position? Pen up, exactly. So you could type pen up, then set position, and Tracy will go right to that spot without leaving anything on the screen to begin your drawing. Oh, here's one you've all been waiting for. Speed. Wouldn't it be great if Tracy could move faster so you could just get the program, especially when you're drawing a lot of stuff? So the command here, it's just called speed. And then in parentheses, you're going to put a number from 0 to 10. Now, the weird thing is the slowest speed is a 1. 10 is very fast, but if you want the absolute maximum speed, you're actually going to put in a 0. So in general, if you don't care about watching Tracy take her time going through whatever programs and command you have written, just start your line 1 by typing speed 0. And that way it'll always go as fast as possible. And then again, you can look at these examples. It's just having Tracy move at different degrees, moving forward, backwards, and so forth. Here's a cool one for circles, to have Tracy draw 4 circles at the center of the canvas. And so here's that canvas again at 0, 0. And to be efficient with this, I could just have Tracy draw each one at a time, but we can be a bit more efficient if I start Tracy down here, remember she always draws a circle from the bottom. I could have Tracy draw one circle, move forward, draw another circle, right? And that's kind of going to be repeated. She's going to do the same command twice. Then I can just set her position to right here and do the same command again. So you can kind of try to be efficient that way with those 4 circles. So here are your new commands. You already should have left and right in your Python notebook, but put set position and speed in there. These are the new ones, set position and speed, to move her to a specific coordinate or to change Tracy's speed of moving through commands. So those should definitely be in your Python notebook so that you can refer to those in later challenges. And again, if you want to look at these again or examples, it's all right here in your CodeHS editor. Once you log in, you can go view these exercises again. All right, the last thing that I wanted to get through right now before I let you code are comments. And a comment is something that is useful in every single programming language. And it's basically just a comment. It's a phrase, it's a sentence that is simply in your code, in your program, that doesn't run. It doesn't like change or affect Tracy at all, but it's there to provide information to either you, the programmer, or maybe to another user, maybe someone else who's looking at your program to kind of help them understand what you are typing or what you're intending with a piece of your program. And the nice thing is, if you've got a comment, the computer completely ignores them. It's just there for a human who's reading it. And so they help us keep track of different coding decisions. Like if you're doing something that you're not sure will work, maybe you're going to put a comment in that program, especially if you've got a program that's maybe a few hundred lines long. You might want to break it up and say, hey, this section of code is doing this. This section of the program is doing that, just to help remind you what it's doing. And there are 2 ways to write a comment. So definitely put these in your Python notebook as well. If you want a single line comment, if like you just want Python to ignore whatever you write on a single line, just type a hashtag, then everything that comes after that hashtag on that same line will be ignored. Now you could type a command first, then after the command, you could put the hashtag and write, hey, this is what this for loop is going to do. And it will still run that first part of that line and just ignore that hashtag and everything after it. But if you have multiple lines, like what if you have a lot to explain, like here's the purpose of this program, this is what I was trying to do, I hope you like it, I don't know if this part works, that's going to be really, really, really long on a single line. You can do multiple lines by just putting 3 quotation marks at the top, then everything in between it will be ignored, and then at the bottom do 3 more quotation marks. And then after that, then it'll start reading all the lines after that last set of quotations for multiple lines. So just in my example here, if I were to say, this has Tracy draw a square. So notice how it even changes color. So it's green instead, starting with this hashtag. The program still runs exactly the same way. It's completely ignoring this hashtag and everything after it just on this one line. So the rest of it works. It's just there to give additional information to the user or the person programming it. And again, if you want to do multiple lines of code, just do a triple quote. I can type multiple lines that will be ignored. And then I could say left 360. So the program still runs, draws the square, ignores all this, then has Tracy just spin in place one full circle, which is 360 degrees. So all of this here in between these will get ignored. All right, do you have any other questions for now? Open up your Chromebooks. I'd like you to try to get through Lesson, well, this comment one is lesson, is it 6, I believe? Yes, so I'd like you to get through lesson 6. If you're still on some of the earlier ones, that's fine. You can work on those. If you're stuck, let me know. Whether you're here in the classroom or whether you're at home listening to me still, just let me know and I can help you out if you're stuck on a certain challenge or anything like that. And I'll give you a hand. All right, have fun coding. And I'm going to touch base with you again in, I don't know, let's see, maybe 45 minutes or so. We'll see how far you can get. Good luck, everyone.